With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, we have a question here. The question says SI unit and CGS unit of certain quantity vary by 10 to the power 3 times. That quantity is, so we have four quantities here: Boltzmann constant, that is Kb. Secondly, we have gravitational constant, that is G. We have Planck's constant, that denoted by H. We have angular momentum, that is denoted by L. So we will write down their dimensional formula first. So what is the dimensional formula for Boltzmann's constant? That is m L2 t to the power minus 2 k to the power minus 1. For gravitational constant, we have dimensional formula m minus 1 L3 t to the power minus 2. And for Planck's constant, we have m1 L1 t to the power minus 1. For angular momentum, we have m1 L2 t to the power minus 1. Now, what are the units that are used in CGS and SI system for mass, length, time, and temperature? So for mass, in SI unit we use kilogram, and for length we use meter, for time second, and for temperature Kelvin. In CGS unit we use gram, then we use centimeter, then we use second, and temperature we use Kelvin. So temperature and time both are same units in SI and CGS system, but mass and length they vary in the two systems. So here in SI system, and this is our CGS system, if we have mass and we have length, we will use here kilogram, and here we will use gram. For length we will use meter, and here we will use centimeter. So their ratio is 10 to the power 3. Here we have ratio 10 to the power 2, because 1 meter is 10 to the power 2 centimeter and 1 kilogram is 10 to the power 3 grams. So now let us put these values in these m and l in each of the quantities. Then we will get how much they vary or what is their ratio. So for straightforward, we will write Kb, and this is m L2. We will neglect T and K. So this will give us, for mass we will put 10 to the power 3. Then for length we will put 10 to the power 2 to the power 2. This will give us 10 to the power 7. This is 4 and plus 3, this is 7. So here they will vary for Boltzmann's constant 10 to the power 7 times in both the units. For gravitational constant G, we will write m minus 1 L3. We are neglecting time because this is same in both the units, SI and CGS, it is second. So for minus m, we will write 10 to the power minus 3. And for L3, we will write 10 to the power 6, because this is 10 to the power 2 and this power raised to 3. This is 10 to the power 6. This will give 10 to the power 3 minus 6. So this will be 10 to the power 3. So for Planck's constant h, we will write only the mass and length dimension. This is 1 and this is also 1. So we will get 10 to the power 3. This is 10 to the power 2. This is 10 to the power 5. Last we have angular momentum L. For that we have m1 L2. We are neglecting the time. Here we will get 10 to the power 3. Then we will write 10 to the power 4, because 10 to the power 2 raised to power 2. So this will give 10 to the power 7. So this column represents the variation. variation in SI to CGS unit. So the variation is how much? For Boltzmann's constant it is 10 to the power 7. For gravitational constant it is 10 to the power 3. For Planck's constant it is 10 to the power 5. Then for angular momentum it is 10 to the power 7. But we have been asked in the question where the variation or the quantity vary 10 to the power 3 times. As we can see in the gravitational constant, the unit in SI and CGS vary 10 to the power 3 times. So here is our answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.